Hi, my name's Peter Shields, and on behalf of AirMet Scientific, I'm very pleased to welcome you all to today's webinar, Understanding the Importance of Respirator Testing, presented by Sophia Chew, the Health and Safety Product Specialist from TSI Incorporated. Established in 1984, AirMet Scientific is a market leader in the supply, service and rental of occupational health, safety and environmental monitoring equipment. With offices in Australia and the Philippines, AirMet delivers world-leading technology for a range of applications including air sampling, dust monitoring, gas detection and more from international and local suppliers such as TSI. We're also able to offer tailored solutions designed specifically for your local conditions and regulations. So I'll now hand over to Sophia Chew, who will provide you with more insights on the importance of respirator fit testing methods and OSHA quantitative fit test protocols. Over to you now, Sophia.
Okay. Hi, morning everyone. I'm Sophia Chew, Product Specialist, Health and Safety with TSI. I'm based in Singapore. Today I'm going to talk about the importance of respirator fit testing, the efficient, reliable methods of using quantitative fit testing. Okay, and the contents I'm going to cover today this morning is understanding respirators. There are various respirators out there in the market. Which of them could effectively be fit tested? Occupational health effects of not using the right respirators, of not putting on the right fitted respirators. Respiratory protection programs, which basically covers how you're going to fit test, who are the persons going to do the fit testing, fit test methods available in the market, including traditional methods and of course TSI methods, OSHA fit test protocols and procedures, quantitative fit test technology, what are we using, and customers' references. Okay, for basics, I would like to differentiate between the face mask and the respirators. Typically, you've seen both in a healthcare setting. Okay, a respirator is NIOSH certified. Okay, so this is a form of respiratory protection, but not for a face mask. Face mask is not NIOSH certified. Face mask does not provide any protections against fine particulate aerosols. So in the general industry, you will not be expected to see them. They do not provide respiratory protection at all because they do not seal tightly to your face profile. That is on the face mask. Whereas respirators, it is able to provide the right protections against the contaminants available in the environment. And you can see that for typically a 3M respirators, disposable respirator, you will be able to see there's a NIOSH printed onto the filter media. There'll be a NIOSH certified printed onto the filter media. Okay, one of these respirators out there is known as non-powered air purifying respirator. So air is inhaled through a filter cartridge onto a face piece. Okay, these are the fields that is shown here. It could be a disposable respirator, a full face respirator, or elastomeric respirator. Next is a power air purifying respirator. Air is mechanically drawn through the filter cartridge. So the air is pulled in and is filtered, and the clean air will be blown out to the user. Not all of this can be fit test though. Not all of these can be fit test, especially those loose fitting hoods. We only fit test tight fitting respirators. Okay, and the next is supply air respirators, or you call it air line. Air is supplied through a hose from a compressor or compressed air cylinder. So this is basically a clean, uncontaminated source is being drawn in. The last but not least is the SCBA, which typically is seen by the firefighters or the scuba divers, right? Breathing source is carried by the user. They carry this cylinder tank with them, okay? So these are typically the respirators that we can fit test them. Okay, this is extract from an OSHA website of the common aerosol exposure limits. So exposure limits in excess of PEL, permissible exposure limits, will be cited here. These are the common ones: silica, lead, hexavalent chrome. Hexavalent chrome is very common in the sense that you can see that in the applications involving weldings of metals. Coal dust as well. So for a worker's time weighted average, for example 8 hours, they cannot exceed this much of aerosols. Okay, so if they exceed this much of aerosols, they have to go through engineering controls, and if it's not effective, if the engineering controls are not effective, the last resort is to use to donor respirators. Okay, so PEL, permissible exposure limits, is regulated by OSHA. Okay, and lately OSHA improved silica materials to a new standards, which is 0.05 milligram per meter cube. That means a small amount of silica could create health hazards. Okay, so now a lot of workers, employees have to relook these standards again for silica. Okay, I'll show you some of the occupational health effects. Silicosis, occupational lung disease is one of them. Okay, raw materials like silica, also known as quartz, are commonly found in constructions, minings, plumbing, paintings. So when welding works happens, welding, drillings, grinding of these raw materials, this crystallized silica is being exposed. And what happens when it's being exposed? When the workers breathe in them, it actually goes through the alveolar sacs. Means it goes through the bloodstreams, and it's difficult to clear out by the mucous membranes. So it stays into the body. And the next is pretty common, it's known as the black lung disease. Again, this is very common in applications such as workers working in a coal mine. Okay, we call it coal worker pneumoconiosis, CWP in short. And of course, some of this CWP is a reaction to accumulated dust in the lungs, and it may get worse during your exposure to the dust or after your exposure has ceased. So it also means that it can actually come out and surface after the worker has retired. So a lot of cases when the worker has retired, all the issues of this starts coming out. Okay, so when you mentioned that a lot of times when we find wearing the right respirators for that contaminant environment, what could result the hazards enter into the breathing zone? First, it could be the respirator that does not fit. Uncomfortable respirators means the respirator is not comfortable enough. Actually, a lot of this associate with not providing the right training to the users, means the users have not attended the right training of how to properly don the respirators. Okay, or improper storage, you didn't store the respirator in the correct conditions, high temperature and stuff like that. And of course, if you readjust the fit in your workplace environment. So any of this could result the hazards entering the breathing zone, even though you want a respirator, even though you want a respirator for that contaminant. So all this could potentially result the hazards entering the breathing zone. In the health and safety aspects, respiratory protection is the foremost frequently violation in the general industries. Okay, so what is the serious violation, which includes lack of medical evaluation for worker required to wear respirators, not conducting initial fit testings, not conducting annual fit testing, allowing a respirator to be worn with a beard. So these are the 4 serious violations in the respiratory protection. And the key thing is, I'd like to stress this too, not conducting initial fit testing, not conducting annual fit testing. This is part of respiratory protection. And of course, workers wearing a beard, donning tight-fitting respirator, they die when exposed to IDLH, atmosphere that contain immediately dangerous to life and health. Okay. Also, incidents in the States happens when the workers with beard, they wore the tight-fitting respirators, and of course not doing fit testing, fit check, and all this on site. So these are very crucial and can be prevented when the workers are made to do fit testing, wearing the proper respirators, and performing fit check. Okay, one of these incidents also occurred in Malaysia, Petronas-owned plant. There were 2 workers found dead in ammonia leak at Petronas plant and 3 more hospitalized after inhaling the gas. Okay, there could be contract staff coming in, and of course, no proper fit testing was being done, although they don respirators, but no proper fit testing was being done at all. Okay, so all these incidents on site can be prevented if the workers wear a tight-fitting respirator, did a proper fit testing. Next, I'll bring you to what is Respiratory Protection Program. Just now we talked about the respiratory protection. What does it encompass? It encompasses a written respiratory program by the administrator, perform an exposure assessment at site, what is the contaminant in the environment, the workers have to go through medical evaluations to see if they are suited to even don a respirator, because the respirator is very taxing for the lungs. So if they have passed through the medical evaluations and they have gone through respirator selection as well, so probably if they're having a 3M respirators, the 3M personnel will come in and teach them how to properly don and don off the respirators and how they should maintain the respirators. Last but not least is respirator fit testing. Respirator fit testing is also one of the critical components to a successful program, and this should not be neglected. So we'll cover in detail what is RES fit testing, how do you perform a fit test, who needs to be fit tested, and when should we fit test. So what is respirator fit testing? Practice of determining if a specific mask or even respirator fits to a person's face. Okay, you can see the highlighted zone here in pink. Because the mask comes in different shapes, forms, model, so we need to select the right shapes, form, model of respirators, size of respirator that fits us. And again, for example, a 3M size S disposable respirator might fit you. Another brand or different type of respirator with an S might not fit you. So you have to fit test to make sure that particular size, style, model of respirator fits to your face profile. Why should we fit test? Again, safety is very important. This is what fit testing is all about. Wearing respirators, ensure that we are protected. Comfortable, so that we are comfortable and we can perform our work duties during 8 hours. If it's not comfortable, we tend to shift the respirator, remove them and stuff like that. Once you remove, we are being exposed, right? Training, the wearers know how to properly don, not only don, actually don, remove the respirator is equally important as well. We do not want to be pulling our hair off. So these are the 3 main aspects why we should fit test. And of course, employee comfort is always the priority. They should be given a reasonable opportunities to select a different respirators. That means they should have a different make, model, size of respirators available to them. And who needs to be fit tested? Okay, if you can see the picture here, so of course in the healthcare industries, we have the nurses, doctors, we have shoulders, we have firefighters, of course chemical, biological personnel, military, all this needs to be fit tested. As long as you are wearing a tight-fitting respirators, you are required to be fit tested under the Respiratory Protection Program. Okay, again, miners, welders, or those all about chemical spills, right? You are required to don respirators to handle contain the chemical spills. In the offshore oil and gas platform as well, toxic chemicals present in the environment, chemical plants leaking ammonia gas, etc., etc. So all these personnel definitely need to be fit tested. So when do we fit test? Okay, for OSHA, prior to initial use, means the first times when you are given a respirators, you should be fit test in that respirators. And it has to be done annually. Okay, and next, if a different respirator is used, for example, a personnel might have 2 different respirators, one for normal workplace process, another one for emergency, so he might be issued with 2 respirators, right? It has to be fit tested twice in both respirators. And next, if there's a changes in the employee's physical condition that could affect the fit, for example, cosmetic surgery, facial scarring, dentures, and the last but not least is, of course, the obvious change in weight. So the rule of thumb, if employees gain 10% or lose 10% of the body weight, he has to be fit tested again. Okay, next I'll discuss the various fit test method that's available in the market, and it's actually regulated by OSHA 29 CFR 1910.134 under the Respiratory Protection Program. So the first is qualitative fit test, which utilize saccharine solution, bitrax solution. These are the pretty common ones in the market. Quantitative fit test, which is what TSI is offering. We call it the ambient aerosol condensation particle counter. In short, you call it CPC. And the next is the control negative pressure. Okay, I'll specifically touch on qualitative and the quantitative. Okay, qualitative we call it subjective methods. Okay, first before you even go for fit test, the workers have to do a pre-taste screening. Pre-taste screening meaning it has to be taste with a sweet solution, which is saccharine, or bitter solution, which is the bitrax. So he has to taste which sensitivity, he has developed sensitivity to any of the taste solution. For example, he tastes with the bitrax and he has to be pumped. It's a manual pump or there's automatic pump. So the manual ones, the personnel have to squeeze the number of pumps. And if the workers can taste the solution, he will say, yes, I can taste it. So when it comes to the fit test, he will be fit test with the solution. And it's pretty subjective in the sense that it depends on the user to say yes if you taste it or no if you don't taste it. And everything is quite manual, including document the data. Everything is manual. You have to be written down. It's not an automatic process as well. And a lot of times we realize that a lot of workers out there might not have taste sensitivity to any of the solution, either bitrax or saccharine. And when you are doing the pre-taste screening test, when it comes to the actual fit testing, you're already overwhelmed with the solution. So you might not be clear with it. You're already tasting it during the pre-taste, or you're actually tasting it during the fit test, right? But for quantitative fit test, it's not a manual process. It's pretty straightforward. It's automated. It's by using a machine to calculate the fit factor. Okay, it's not a subjective method. We don't wait for a response from the users if you taste it or not. The machines will automatically generate the results, and this result will be automatically stored into the systems. So it's a very automated process. Okay, and the advantage of using, I'll list a few advantages of using qualitative fit test and the quantitative fit test. So let's look at the qualitative fit test. The advantage of qualitative fit test, it is low equipment cost. Disadvantage, which I mentioned earlier, is very subjective, it's inaccurate, could be error prone. Okay, and of course, storing the data is very manual. You have to return it down and probably you have to key them back into the computer itself. It's not suitable for all people. It depends on taste sensitivity to an individual. Next, I'll discuss more on quantitative fit tests. Of course, there's numerous advantages using quantitative fit testing. It's pretty accurate. It's automated test, including the test results. So everything is automated, from doing the fit test exercise all the way to storing the test data. Okay. It can be used for training purposes because there's a real-time check. How you properly don the respirators, you can do a real-time check. So there's training purposes, easy to use. You don't have to prepare the user, or the fit testers do not have to prepare any chemical or test solution. So it's pretty safe. But the disadvantage, of course, is the higher investment cost. And it's just a one-time investment cost because there's no consumables like solution to purchase. Okay, so what is quantitative fit test? It's the assessment of the adequacy of respirator fit by numerically measuring the amount of leakage into the respirator. So it's an objective method to test how a specific make, model, size of a mask fits to a specific person. And how do we calculate a fit factor? What are we trying to challenge against? Fit factor is derived by concentration outside the respirator versus concentrations that goes into the face seal. So we are trying to challenge against the ambient particles and how much of these ambient particles leaks into the respirators. That's how we derive a fit factor. And this is automated resulted by the instruments. So it's ambient particles concentrations versus particles that leaks into the respirators. Okay, this table shows you OSHA's approved minimum fit factors. For a full-face respirator, minimum fit factors have to be 500. For half-face respirators and filtering face pieces, minimum fit factors have to be 100. So it means that you will pass that respirator make model size with these values here. So you will be issued the make model size respirator as long as you pass the minimum fit factors. And again, these fit factors may be different. It could be you have to refer to the governing protocol information. So again, for example, a firefighter in the States might require a minimum fit factor of 2,000. Okay, it really depends on the governing protocols. But as long as you pass the minimum fit factors mentioned here, you are able to have that size model style of respirator issued to you. So if fit factor is above 100, you must use quantitative fit testing, because just now we mentioned that only half-face respirators and filtering face pieces minimum approved fit factor is 100. So for a fit factor, for a respirators, full-face respirator, minimum fit factor is 500. You must use quantitative fit testing, which is this equipment here, but not the qualitative fit testing equipments. Okay, so for full-face respirator, minimum fit factor is definitely above 500. You have to use quantitative. That is based on OSHA protocol 29 CFR 1910.134. Okay, I'm not going in details to what is the difference between assigned protection factor and fit factors, but just to highlight to you, when we are doing fit testing, we are fit testing the respirator alone. We are not fit testing the systems, including the tanks, the pressure gauges, the alarms. This will have to be removed, and when you comes in, it's just the face mask, that's all. Okay, so when you comes in, we will have to convert that to negative pressure mode, or you call that air purifying mode. So we'll remove the cylinder tank and convert that to a negative pressure mode. And then it's only quantitative fit testing allowed. Okay, this is a study conducted by NIOSH back in 2007. It's trying to evaluate the performance of N95 respirators with the different fit test methods, and of course without fit testing as well, and also with surgical masks. So the x-axis, y-axis here basically shows you the different fit test methods available, and the x-axis here will show you the simulated workplace protection factor. The higher it is, the values, the better you are protected. So 1 basically, if a value of 1 basically shows no protection at all. A value of 10 and above shows somewhat kind of protection. So a value of 10 means that the air inside the respirator was 10 times cleaner than the air outside. So when you see, so you can see that a quantitative fit test method with PortaCount gives you the most highest level kind of protection. Okay, and of course surgical mask doesn't provide any protection at all. And using fit test methods such as qualitative, it provides you a 10 simulated workplace protection factor. Of course, the best is PortaCount qualitative fit test. It gives you 20 times much better protection. Okay, next we are going to some OSHA fit testing procedures and protocols and guides to show you how fit testing is being done. Okay, of course, before you even start the fit test, you have to go through these 5 important steps, which includes there should not be any hair growth like beard, clothing, or jewelry that will interfere with a proper fit. So when the workers come in, you have to go through all this process and consider important considerations with them. You have to check there's no beard, clean shaven face, there's no clothing or jewelry that will obstruct with a proper fit. And any time if the test subject exhibits difficulty breathing, you have to stop the test and refer them to a healthcare professional. And of course, if the employee finds the fit unacceptable, it's not comfortable, they are allowed to choose a different respirator. So earlier I mentioned that the employee comfortable is very important, right? They should be given reasonable amount of respirator to choose from. And the last but not least, of course, no smoking for the last 30 minutes because smoking emits particles. And just now I talked about we are measuring particles that leaks into the respirators. So this will interfere with the results. So these are the important considerations before the personnel can even start the fit test. And when I mention no beard, it should be clean shaven face, which is shown here. The second picture here, this is the right one. Okay, especially when you are wearing full face respirator, even a slight snort, it will push your respirator, full face respirator out. So this should be considered. Okay. Okay, next, the workers are required to choose a respirator, so they have to choose a respirator which provides the most acceptable fit. That means they have to have different respirators available, and they have to hold it to the face to see whichever is provide a better fit. Okay, so they could choose 2 respirators, and if one does not pass, they always have another respirator to fall back on. And of course, they have to provide training on how to properly don and don off the respirators. Normally, the mask manufacturer like 3M will come in and teach the users how to properly put on the respirator and remove them. Okay, and of course, what I'm trying to show you here is also if you are using quantitative method, you can use a real-time check in the instruments to show you how to properly don and remove the respirators by using a real-time check fit factor display in the unit itself. So the instrument itself can actually provide some form of training to the user. Last but not least, you have to install the fit test adapter. You see on the right side, on the disposable respirator, they probe the respirators. So there will be a tubing connected to assess the breathing zone, and there will be another tubing to assess the environment. This is the pictures on the right shows a elastomeric respirators. Again, there will be a tubing access into the cartridge, into the breathing zone to assess how many particles is in the breathing zone. And there will be a tubing in the environment again. So last but not least, you have to cover it up with a P100 filters. So minimum, it should be using a P100 filters. Okay, so this is how you install the fit test adapters. This will be a consumable parts. And we have different fit test adapters available for different mask models, different mask brand as well. Because of the connection is different. Like typically for 3M, it's quarter turn or bayonet. But for other respirator model, it could be a screw-on cartridge, screw-on filter. So these are all available with TSI. And next is the fit test procedures, which include assess the comfort and fit for the workers. You have to assess the comfort and fit for 5 minutes. That is stated by OSHA. Okay, you have to make sure the position of mask on the eye, on the nose, is not too high on the nose bridge, and chin is properly placed. The adequate strap attention for a full face respirator or elastomeric respirator, you have to make sure that it's not overly tightened. If not, it will induce a leak. Right? Is there a tendency for respirator to slip as well? So all these have to be checked before the workers go for fit test. And 5 minutes assessment is very reasonable because during 5 minutes you can do all this assessment, and 5 minutes you can assess if it's comfortable enough for the workers to don the respirator. If these 5 minutes they don't feel comfortable, I think it's good that they change to another respirator straight away without wasting time for the fit testing. And then next is, the last but not least, is to conduct user seal check. So they have to conduct both, check positive pressure check and negative pressure check. Then the fit tester will provide a description of the fit test exercise. And of course, last but not least, they have to don any applicable safety equipment that may be worn during actual respirator use. For example, firefighters, they are wearing full PPE suit. They have to come in with the suit because it could interfere with the fit of the respirators. And like, for example, if you are wearing earplug and you're coming for fit test, you should be having them on as well. Anything, safety equipment that may be worn during actual respirator use have to be worn during your fit test. Then the fit test starts. It's for OSHA protocol, it includes those 8 exercises, which is normal breathing, deep breathing, turning head side to side, moving head up and down, talking, grimace, bending over, and the last is back to normal breathing. Okay, each exercise takes 60 seconds. So the overall test exercise is 7 minutes and 15 seconds. Grimace is an exercise that only takes 15 seconds. Okay, grimace test result is not considered because grimace is just a momentarily to break the seal of the respirator to the face, and it only takes 15 seconds. So the task is to do some is basically the user have to intentionally break the seal. So it's to verify if the respirator will receive specs properly for the last 2 exercises, which the last 2 includes bending over and normal breathing. So this test result is not included at all. And OSHA is only concerned with the overall fit factor, but not the individual test results. Okay. And again, you can see that this 8 exercise actually mimics workplace motions because in the typical workplace, when you are issued a respirator, you don't do the work sitting down. You typically walk around. You might be turning your head side to side. You might moving your head up and down, and you also talk during your workplace. So typically, this exercise is very valid because it mimics workplace motions. So these are required to do. And a lot of times when in normal breathing or deep breathing, you might pass with that particular style of mask, but once when you turn head side to side or up and down, you can see the mask probably starts to leak at the side because of your movement. You're stretching your neck muscles, especially on donning a full face respirator, or when you're stretching your neck muscle, you can see the leak starts to occur. So this exercise here is very valid. Okay. And of course, OSHA recommends that the records of the fit testing has to be last until the next fit test exercise. So the test record must include the name of the person being fit tested, the type of fit test performed. Is it qualitative fit test or is it quantitative fit test? The make model of the face piece tested, the result of the test. Is it passed or is it failed? Okay, and the fit test record, which I mentioned earlier, must be maintained until the next fit test. And of course, for TSI Fit Pro software, using the quantitative method, we have a useful tool to help customers manage their fit test data effectively, which they are able to store the data into the systems. They are able to pull the data for the next fit test. They are able to pull the data who failed the fit test and whose fit test is coming up. These are all in the Fit Pro software systems. Okay, next, I'm going to talk a bit about our PortaCount technology. Okay, just now I mentioned a few times about we are talking about particle concentration in the environment and versus how many of these particles leak through the breathing zone. So we talk about number of particles per cubic centimeter. And for PortaCount, what is the particle size range that these instruments can see? You can see the size range down to 0.02 micrometer to 1 micrometer in particle size. And you can see 0.02 is very, very small. It's nanoparticles. And how does this equipment work? What do we call it? This equipment, we call it condensation particle counter. How does it work? Next slide, I will show you in details. Okay, you can see there's 2 tubing. One is hooked up to the breathing zone. Remember, I have a tubing that goes into the breathing zone, and I have a tubing that measures ambient particles. So there's 2 tubing. Okay, and I will have a cartridge soaked with alcohol, and it has to be a reagent alcohol, 99.5% pure alcohol. So I will soak the cartridge with this alcohol and I'll put into the unit. And particles coming in, so particles coming in will be mixed with the alcohol vapors. When they are mixed with the alcohol vapor, they go through this cooler chamber here. When it goes through this cooler chamber here, the alcohol will condensate on these particles. So when the alcohol condensates on the particles will grow in size. And then they can be counted as one particle. So this is how the instrument sees the particles coming in. Okay, so that's why our alcohol, 99.5% reagent alcohol, is very important. Okay, and since we are talking about nanoparticles, typically we are using this alcohol to condense it on them and to grow the particles to a size that the laser can see and detect them and count them as one particles. So how this is CPC technology works. Okay, and we have two models here. 8038 is typically, we call it PortaCount Pro Plus. This is the equipment that can fit test full half face mask and all filtering face pieces. We have another model is 8030. This 8030 can fit test full and half face elastomeric mask and filtering face pieces above 99% efficiency. That means for model 8030, it cannot fit test respirator N95%. Okay, it cannot fit test respirator N95, P95, R95. No. Okay, so only model 8038 can fit test all respirators. Okay, and you can operate the PortaCount in two ways. You can use the computer to control it, to control the unit. So you have to connect a USB cable to the PC. And the next step is also to use a standalone mode. You can have a USB flash drive with database plug into the instruments, and the data will be recorded into the USB flash drive. So when you are back to the office, you can actually export this data to the computer, back to the PC. So there's two ways you can operate the instruments, in a computer mode or in a standalone mode. Okay, this is a summary of the earlier presentation that I mentioned. So in order to make your program more efficient, what can these instruments or PortaCount do for you? You can train the user how to properly don or don off the respirator using a real-time fit check. So it basically saves you the time to select the respirator that fits you, and it shows you how a good fitting respirator should be. So if you are able to do this by showing your workers how a good fitting respirator should be, they'll be more comfortable in wearing the respirator, and they'll be more comfortable to perform the work tasks in that environment, in the contaminant, in their work environment, because they know how well a good fitting respirator should be. Okay, and it's automated fit testing. That means time spent in each exercise is consistent. 1 minute each exercise is taken. And of course, there's less chance of error. And last but not least, I mentioned we have a very efficient database that we can actually keep track and record all this data that has been generated. And we can even keep them and record them until the next fit test as well. So these are the three important functions of the instruments that you can provide for the customers. Okay, customer reference, we have in the hospitals settings, we have especially during the SARS period in Hong Kong, government hospitals, they are mandated to do fit testings using quantitative or PortaCount methods. Okay, drugs manufacturing, pharmaceuticals, Novartis, Merck, emergency respondents, they are using a full face respirators, Shell, ExxonMobil, industrial, could be Petronas, oil and gas, offshore plant, chemical plants, Chevron, of course, mask manufacturer as well, 3M, Scott Safety, they are also our big users. They typically use our unit to show the end customer, their end customer, how which particular mask suits them, and they actually show their end customers which particular style of mask is benefit for them. Okay, so these are typically our key main customers. Of course, you have more than that. Okay, for this, I end my slide.
Thanks everyone for attending today. And finally, Thanks, Sophia, for your time today. We appreciate the insights you provided into respirator fit testing.
Thank you, everyone.